Hello everyone, I am Aditi Kumar and welcome to another conceptual learning related to optimization. Especially this is a very introductory and conceptual session related to optimization, and I can say this is the first video in our optimization related playlist. So before going to technical depth or directly implementing into machine learning and data science models, I want to cover some conceptual things related to optimization, because we covered the optimization name, I can say some introductory thing during our mathematical big picture video, but today I need to highlight some of the conceptual things, or maybe I can say what will happen if you will not use optimization technique properly, or maybe I can say what is the benefits while we are using any optimization techniques. So I will cover some of the basic fundamentals of optimization, and then maybe starting from next video I will specific to implementing the thing into, I can say, in the machine learning or data science models. Let's start for today. So if I am talking about introduction to optimization, so specially I can say I need to first cover what exactly the optimization is. So optimization is specially a branch or maybe a technique under mathematical concept or mathematical foundation, and specially it is dedicated to a specific thing, what exactly it is. So optimization technique is, I can say, optimization is a technique within mathematics, or it is a process of finding the best solution of a problem, any problem. I am not specific to any, whether it is a minimization problem or maximization problem. Whatever our objective with respect to the problem statement, this is the process through which we can get the best solution. This is basically the technique is dealing with that. So if I am just summarize the concept here, optimization is the finding the best solution from a feasible options. The goal here is to maximize or minimize the objective function while meeting the constraints. Constraint means there are certain conditions or criteria we need to follow while solving the particular problem. These are the constraints, I can say. So, and here I talked about objective function. Objective function means what exactly our aim, what exactly we are going to do with that particular problem statement. For example, if we are talking about cost, we need to reduce that. This is our objective. We need to reduce the cost. We need to maximize the profit. It depends basically problem statement to problem statement. And constraint here means the limitations, restrictions, I can say, some conditions. These are the constraints. This is basically the fundamental definition of optimization. We need to get the best solution using the technique. This is the mathematical concept, I can say, or mathematical process we should follow. Let's deep dive into multiple things, or maybe benefit and maybe I can say other concept related to optimization in our further slides. So what will happen if you will not use optimization technique, especially problem solving without optimization technique? So I can say we will follow some guess or maybe heuristic, intuitive approach while solving the problem. Resource intensive, requires time and effort to take the decision. Sub option, I can say suboptimal result, we are missing opportunities. We cannot consider each and every factor while solving the problem. It might be the case at last our solution will fail, because we are basically looking for limited environment or limited, I can say, data, or maybe I can approaches or resources without optimization. Or I can say some subjective, influenced by personal biases. We will always listen to a, I can say, some SMEs, subject matter experts, or maybe some senior persons, because we will think that whatever this particular person is saying is correct. These are the problems actually will arise during our problem solving if we are not using optimization. If I am coming to using the optimization properly, I am using the optimization during my problem solving, what will be the benefits? Or maybe with respect to that particular problem statement, how it looks like whenever we are using the optimization technique. So it will be a systematic approach, structured framework we will follow. Efficient exploration, comprehensive search of the particular problem. We will not let any factor behind. Improved performance, definitely we will improve the performance whenever we will consider each and every factors into our problem statement which is related to our problem statement. Your objective decision making, completely we will basically focus to our goal, our what exactly our objective. We need to follow this particular path. So completely data driven choices. We have the data, we will take decision, or we will go to our goal completely taking the proof, or maybe getting the proof from the data. Or last one is basically optimal solution, best possible outcomes. Whatever the number of outcomes is present, we can basically select the best one while using the optimization technique. These are the basically the benefits, or maybe the problem with using optimization looks like completely different from the problem using without optimization. So what are the basically benefits of the optimization? I can say first one is efficiency, cost reduction. Definitely if you will basically do it efficiently, so definitely our cost will be reduced, will improve the profitability, right? Better decision making, you can take the best decision. Improved performance, these are the basically I can say outcomes from using optimization, because the previous slide was related to how the problem statement or maybe that development environment or problem solving framework looks like. Here what are the outcome we will derive while using the optimization, what will be the benefit to the business. Improve performance and sustainability, minimize the resource consumption. Definitely we will take the best decision, we can reduce the cost, you can reduce the resource. Definitely it will reduction of the cost is directly proportional to the reduction of the resources. These are the benefit we can keep to a business while using the proper or appropriate optimization technique according to our problem statement. So if I am talking about quite detail into optimization technique, so different these are the high level categorized actually I highlighted here. First one is mathematical optimization, second is heuristic optimization, stochastic optimization, dynamic optimization, meta heuristic optimization, global optimization, robust optimization. These are the major category I found. Under that there are multiple specialized child techniques are there. Definitely we will cover in the further videos, but these are the basically the major high level categories of the optimization techniques. Some of the example actually I found here: linear programming, genetic algorithm, Monte Carlo simulation, your gradient descent technique, or different flavor of the gradient descent technique. Each category tells you the different problem complexities. Definitely different to the, it depends to the what are the complexity of the problem, or what exactly our problem statement is dealing with. According to that we should use the appropriate solution or appropriate optimization technique. This is the beauty of using the optimization technique in the problem statement, because certain optimization technique is specific to solving the particular problem statement. That's why type of the problem, complexity of the problem, according to that we can take decision. We can take decision to adopt the proper approach, proper optimization technique. So if I am going to last concept here, how the real world application is happening. What is the real world application with respect to optimization, or what is the actual the real world application behind which we are using the optimization technique. If I am talking about engineering perspective, These are the major areas actually where optimization is playing a very vital role. So design, resource allocation, these are the major areas under the engineering we are using optimization technique are being used. Finance is a, I can say, very major area where portfolio optimization and risk management, very important concept in the financial market. We are using that optimization technique. Operational perspective, supply chain and logistics, we are using optimization technique to take the best decision. In the health care, if I am talking about treatment planning, resource allocation, these are the areas of the healthcare domain we are using the optimization, or optimization technique is being richly used. And the last one is a transportation technique, in the basically the route optimization and the traffic management. These are the application areas. So let's summarize actually in a pictorial manner. So if I am talking about mathematics, one concept is optimization, one process, one technique, which has different type of or techniques, child techniques actually associated with, right? So we are having different domains: transportation domain, finance, operation, healthcare. These are the domain. We are using basically multiple techniques, or maybe this way, multiple techniques according to the problem statement. That doesn't mean that one particular technique will be used in a particular domain. No, every technique solving the problem, their business are getting outcome from here, from the different domain. We are using appropriate optimization technique, or whatever the things or modeling we are using in data science, also in machine learning, also behind that correct or maybe appropriate optimization technique is getting used. My next video actually I am trying to put it specific to data science, but here actually it is generic actually with respect to data science, with respect to optimization only. But this is the hierarchy actually related to optimization, and optimization basically is getting used behind the a particular model or any specific model, whatever the model actually we are putting in different domains like transport, finance and operations, or healthcare. So that's why I thought before going to into depth or directly implementing the thing into any model, so I will basically provide some content or provide some fundamental things related to optimization, so that it will be very beneficial to understand the mathematical concept related to it, and how it is basically related to different problem statement. So the next video I am planning to take into specific to data science, in whenever we are talking about any data science model, how optimization is playing the role there, different role. So definitely we will dig dive into that in our next session. Thank you very much for watching this particular video. Please do subscribe my channel and share this particular video, so that others can get benefited out of that. And please put comment under this particular video. Also enable the notification, so that you can get notified whenever I'm putting any new content or new conceptual videos. Once again, thank you very much for watching this particular video.